Geologic geometry question at an ordinary level. On the drawn supply, draw a vertical section profile on the line AB. So with that done, we've taken each point where a red contour hits the line AB, we projected it up to the elevation here, and we put them at the appropriate heights. We've got the lowest contour first, that was the first one, then we went up along. Okay? Now, part B then, C, D, D are outcrop points on the top surface of a stratum of ore. So the stratum of ore is basically a lump of some material you'll be mining out of the ground, right? Say iron ore, right? CD, huh? Yeah, well spotted, Sherlock, right? Now, determine the strike and dip of the stratum, right? So again, the strike is the bearing of any level line, and the dip is the angle that the stratum makes with the horizontal, okay? So first of all, I'll highlight my stratum of ore and plan with outcrop points C, D and E. I'm recording it for the benefit of those boys that are gone looking at cows and fields and stuff. Now, so C, D, E, right? Now this is it in plan, so when we look down, there's where them points are. Now we notice E is on a contour line at what height? 35. D is on one of 50, and C is on one at 70. So when I'm getting them points above in the elevation, I can project them straight up. E goes straight up, D will go straight up, and C will go straight up, right? Now what heights are they? E we know is at 35, right? So you follow the line up, that's where E is there. D is at 50, so that's D there, and C is at 70, right? So I'm actually going to have to add one more. I've gone up as far as 65, I need to add one more height up here. That's 70, right? Because C is at 70, so that's C there. Okay? Now, that there is E, this here is D, and this one here is C. Okay? So I'll draw in that. Now it looks there like D is actually above the ground. But obviously, you must remember that this profile there is where? It's on the line AB, right? So it's just taking the heights at that point. Whereas obviously, as you come down here towards this is the highest part. So the ground is getting higher, okay? Now, so the strike is the bearing of any level line in plan. So a level line in plan is basically, it's a true length line. And any line that's a true length in plan, what will it be up in elevation? Be a horizontal line, right? Or line parallel with what we call the horizontal plane or the XY line. So again, you could draw any line in and get 2 points and get the corresponding 2 points down here. But as I said to you yesterday, always use the middle one of the heights. So the middle one here is D. So I'm going to go across from D. And we'll call this here point P. Now point P is on the line EC. So it's very easy to find it down in plan. I project it straight down. Excuse me. Project it straight down till it hits the line CE, right? And that's point P there then. So then that, oops. Then this gives me here, this is my strike, right? Now, put the strike in green there. And I'll just mark it there as a strike. Now, if for example you put a line up here, look, you could call that 1, 2, right? The first one there 1, that one 2. 1 would be on the line CD, so you come down to CD, that'll be 1. 2 would be the line on the line CE. You'd bring that one straight down, that'll be 2, and that'll be a strike there too, right? So it's any true length line on the stratum of ore here, on the top surface of the stratum of the ore, or a plane for want of another expression. Now, yesterday, if you remember, the dip then is when you get a line view of this plane, right, of the stratum of ore. So if we say that CDE here, the 3 points on the set square are the 3 points CDE, right? To get the angle that makes with the ground, you have to get the plane or the stratum, the surface of the stratum of ore, as an edge view or a line view. So we want to see it like that. Now, if we forget about this sheet for a minute, we just think about the set square. If I want to get an edge view of the set square, I take any line that's a true length. So I'll take this line, that's a true length there, because we know it is, right? If I look along that, so if you were to look straight down along that line, what do you see the set square as? A line, right? Or an edge view. So the principle or the theory of it is, if you have the true length line on any plane and you look along that line to draw the auxiliary view that you project will be an edge view of the plane. So like we done yesterday, we look along the strike. Okay, so we look along the strike to do an auxiliary view, and our new XY line our new XY line has to be perpendicular to the strike. Okay, then what we do is we project C up, we project D up, and we project E up. Now, what height is E? What? Now, E we know is what height? 35. Measure up 35 here. Yeah. So that's E. C is up 70. Now, it's not a bad habit to get into it. You get the first one and the last one, right? And join them. And then this one, of course, is up 50. Right? So now I have E here, I have D here, and I have C here. And now I actually have that stratum of ore as an edge view, which is what we need, because we need to calculate, we need to calculate the angle that makes with the horizontal, with the ground. Now, we could join the lines out, right? Basically, that there is the dip. That angle between the set squares is the actual angle, right? I'll use pencils. Is the actual angle between the stratum of ore and the ground, right? That's the dip in there. But because that's going off the sheet, what do we do with our x1, y1? Like, will the angle anywhere there change between the pencil and the blue line there? No. So we just bring our xy line up to the bottom point, like we done yesterday. So again, that's sliding set squares.
How do you get that line you have in blue there?
One sec now, Tommy, sorry. Right? This line?
Yeah.
Well, you projected along the strike, so you're looking along the strike when you get that line.
Yeah, but what way?
This one's, and the heights of them then are, the heights of them up there is E, we put it at the line 35 here because it's on the 35 contour. So E comes up 35 there. D is on the 50 contour, so we mark D 50 up there, and we mark D 50 up here. C is on the 70 contour, so we mark C 70 up there, and we mark it 70 up there. Yeah. Alright? Now, this angle here between the horizontal and between the stratum, this angle here, that's the dip. Okay, and that concludes that one. Now, just before we leave, a couple of basic principles, right? When you get this question, when you get a, sorry, that's not that finished actually. We'll do part C in a second. We'll just do a quick revision. When you get it first, right? You draw in your three lines here. So that's the top surface of the stratum of ore, right? Then we find it up here by simply, this goes back to basic orthographic that you would have done in first year. Looking down here is looking down up, helicopter view, bird's eye view looking down, so that's your plan. Here is when you're looking, basically, if you've got a big knife cut straight down through a B, pulled it away and looked in, so that's an elevation of that. So you have elevation plan now. So if we pick a random point E here, if E is in plan, to get it in elevation, you always bring it straight up to whatever height it is. And we know the height that it is from the contour line, which was 35. So I'd mark that at 35, mark D at 50, and mark C at 70, right? Now, this was a bit more difficult than the previous one because there was a part C in it. The stratum has a thickness of 10 meters. Now, if the stratum is a thickness of 10 metres, what's the thickness of it going to be on this sheet? Bearing in mind that the scale is 1:1000. 10 millimetres, right? So, we know that the stratum is 10 mil thick. In your auxiliary view, which shows the dip. So this is your auxiliary view. It's like the orthographic question where you have a surface A. If you get the true shape of surface A, you project off it, right? Except here we're not projecting off a line, we're projecting along a line. So in this one, it wants us to draw the bottom surface of the stratum. Have we the top surface of the stratum drawn? We have, because remember, CD and E are anchor points on the top surface. So we have the top surface drawn. So now we need to draw the bottom surface here. So, can I measure 10 down there? Or what way would I have to measure 10 from the line EDC? Perpendicular, commander, right? So, what you do is you line your set squares up again, and you come down, we'll say, there. So 10 is on it here, so that's 10 mil away, right? And again, that has to be a perpendicular measurement, right? Because if this is the top, like if you're taking, okay, we can't do it in this room because it's not a flat roof, but if you're in a room with a flat roof and you want to measure the height of it, you don't measure the height, start the roof there and end it over there, instead of being at an angle, you measure it straight down, so it's perpendicular off of the surfaces. So we came perpendicular here, and then it's just sliding set squares like this. And that's the bottom surface of the stratum of over there. Right? And I'll just write it in there, look. 10 meters from the top down to the bottom. Okay? So that's 2015 done and dusted, folks.